Hi, I'm Michael Brand, and you're watching How to Lose Money on Analytics, a video series all about the pitfalls of advanced analytics that we at Optima Analytics aim to help you avoid. Today, I want to discuss big data. Is that still a buzzword? Maybe not. Its heyday was around 2012 or 2013 when companies fearing a data deluge started hiring more and more data scientists. Nowadays, one rarely needs to even say it. All analysts are big data analysts. All tools are big data tools, right? But while we may have stopped using the term big data, much of the corporate way of thinking about analytics was shaped by it. And the unfortunate result is that companies make wrong business decisions over all their data, large and small. So what is big data really, and why, when you're asking for it, you're asking for the wrong thing? For our purposes, big data is characterized by the four so-called V's: volume, velocity, variability, and veracity. Some also add value. Volume means a switch to parallel processing. Velocity speaks about the need for fast, often real-time response. Variability relates to the need to handle non-tabular data, such as graphical, textual, and image data. And veracity means best effort data collection. If fear of these made you hire data scientists, you've already fallen into the first trap of big data. Big data is not the same as big data analytics. You see, big data is a massive $189 billion market. It includes cloud technologies, Hadoop, social networks, your ability to read and write Gmail, but none of that is big data analytics. Now, next to this giant market is a much smaller $78 billion data analytics market. It includes data science, data mining, BI, machine learning, and all other disciplines intent on extracting value from information. Big data analytics, the intersection of these two, is by comparison merely a sliver, accounting for only $14 billion globally. When you're investing in big data analytics, you're investing in that tiny sliver. Is that a wise investment? Is value really a fifth V of big data analytics? The avalanche of headlines promising great value from big data certainly tries to convince you of that, but a point to note is that none of these is a peer-reviewed study. The academic literature about the value of big data analytics paints a far more somber picture. An NYU study by Tambay, for example, concludes that outside of labor markets characterized by high levels of Hadoop investment, the estimated returns to firms' own Hadoop investments were not statistically significant. In other words, big data offered no advantage whatsoever. Even in the exception cases where the paper's research did find value for big data, that value was a 3% productivity growth. By comparison, similar studies for small data analysis found twice the growth for a fraction of the cost. Why is that? Businesses invest in big data technologies because they think they have to. But more often than not, your data is much smaller than you think. A typical organization has a great many sources of data, and these come in all forms and formats. But for most of your analysis, what you look at is data that comes from people. And the bottom line is, there aren't that many people, and we don't do nearly as much as you may think. If you catalog everything that comes from people, it's still very small data. Even as chief data scientist of one of the world's largest telcos, my most frequently given advice to my team of big data scientists was to take the data to be analyzed out of the clusters where it was stored and analyze it in memory using small data tools. Because even in a company that has to deal with millions of events per second, most of the time, the data relevant to any particular analysis fit comfortably on a USB stick. Our impression that our data is big usually comes from, you guessed it, hard disk sellers, or hard disk renters if you're in the cloud. We are being encouraged to keep our information in text rather than binary, to use XML instead of tabular arrangement, to store in Hadoop at the price of massively inflated files and a default of 3x replication, and of course to store the data in a lake, meaning to store it in its rawest form as well as any useful intermediate form, etc. These techniques amount to inflating the stored size of your data by a factor of hundreds. Suddenly your small data becomes big data. But when we do analysis, quite often we ignore all this complexity, put everything in nice tables, store it in efficient ways, and, more often than not, analyze it in memory. All of the R-based computation is in memory. All of the Python-based computation is in memory. Most of the tools that we use are in-memory tools, and for most uses, that's good enough. Going big data means losing access to all these tools that are most data scientists' bread and butter, and moving to an environment where the tools are less mature and less effective. Investment in tools becomes heavy, investment in manpower becomes heavy, and even if you have both of these in place, progress is still much slower and far more restricted in what insights you can get out of it. Algorithms have to be data parallel and quasi-linear. Data needs to be analyzed in situ, sometimes even in a streaming fashion. There are no controlled trials, barely even control groups. Your data is wrong, is missing, is filled with all manner of human errors and biases. You still spend 80 to 90% of your time wrangling and cleaning it. And in fact, big data scientists need to learn entirely new techniques, automated and semi-automated, for data cleansing. But in the end, it's all best effort. There is no such thing as clean big data. Traditionally, scientists obsess over data curation, the basic rule of science being you put garbage in, you get garbage out. But in big data analysis, we don't just throw away the tools of data science, we throw away the tools of science. The purpose is to move to a model of pervasive analysis, surrounding the customer 360 degrees. We no longer just care about their shopping behavior, we want to know everything about them in order to better understand what motivates them and how we can introduce influencers. The problem is that any value received from such analysis is statistically dubious and relies on a causal chain that is tenuous at best. In one famous study linking Facebook likes to personality traits, one of the best predictors for intelligence was a liking for curly fries. Followers of this video series will recognize this to be a predictive statistic, not a prescriptive one, and will know that using this kind of data in your business decisions is setting yourself up for failure. But how do you get statistically defensible results? How do you make sure that whatever conclusions you reach are actually the truth? The answer is that it is possible, but it requires a new and much deeper understanding of the data and its behaviors, something that you generally can't have unless you've already done small data analysis of the same problem first. There is a fallacy regarding big data, that if you simply add more data to your algorithms, the value of your insights will increase. Studies show that this is not true. If you're doing marketing and are looking at all the classic rubrics, the demographics, the psychographics, etc., these will not work any better with big data than with small. They are optimized for the environment in which they've been honed. In order to reap any value from big data, you need to relinquish all the classical theory of the profession and move to entirely new big data native techniques. And again, for most organizations, the ROI just isn't there. Even if you're a global conglomerate, chances are your data can more easily and more effectively be handled by small data techniques. Am I suggesting you should never apply big data techniques? Absolutely not. But they should never be your first line of defense. Don't hurry into big data analytics unless you've first exhausted the value where the majority of the value actually is, in small data. And if, as most organizations I know, you find that extracting value from small data science is challenging, then trust me, big data would be losing your money on analytics. Have you fallen for the big data trap? Tell us your story in the comments below. At Otsma Analytics, we help businesses maximize their value from analytics by replacing buzz and hype with deep expertise and real knowledge. Check out the other videos in the How to Lose Money on Analytics playlist, as well as the other videos in the channel. And don't forget to like, share, and subscribe. Until next time, happy data modeling, and don't get fooled by lies, damn lies, and statistics.